Chapter 3 really starts to get into the economics of environmental economics, and specifically uh, talks about the issue of externalities. If you took the principles of micro class, that is a prerequisite for this one, then a lot of this material will be sort of a review for you, but applied in this new environmental context. So the first thing that they do is remind you of what a supply and demand model looks like. So I won't go through much of the details of this since you did this in a principles class, um, but one thing that you can keep in mind is that supply, another word for supply is marginal cost. Um, Supply has been defined sometimes as the producer's lowest willingness to sell their product. And as you can imagine, your lowest willingness to sell is whatever it costs you to produce. So your supply is your marginal cost, and demand, on the other hand, is the marginal benefit to the consumer. So demand has sometimes been defined as the consumer's highest willingness to pay, and whatever you're willing to pay, you would equal whatever the benefit of that item is to you. So this graph shown here is a supply and demand model for automobiles, showing a market equilibrium price and equilibrium quantity. That is a economically efficient outcome if we go to that equilibrium price and quantity. Um, but that assumes that there are no externalities associated with the market for automobiles. And we know that's not true. So an externality is defined as a cost or benefit to a third party of a particular transaction. So when I go to a dealer and I buy a car and then I start using that car, it has benefits to me. Um, and it had a cost to me. I paid a price that was determined sort of by the cost of production and things like that. But those benefits and costs are not isolated to me and to the dealer. There have been studies that this table shows, and your book talks a little more about. There have been studies that try to determine what actually are the external costs of automobile use. So we know that using a car, for example, contributes to climate change, contributes to pollution. There are accident issues, oil dependency, traffic congestion, other costs, things that cost you because of my choice to drive a car. So that's an externality. And when we introduce externalities to the supply and demand model, it looks something like this. So notice the the private marginal cost of of a car um, is lower than the social marginal cost. So there's some cost to society on top of the cost of producing the car. So the the social supply curve or social marginal cost um, is actually the sum of the internal cost, the private cost of production, and whatever the external cost of that car being produced and consumed are. So the social supply curve actually is above the private supply curve. And that leads to a social optimum. We end up with an equilibrium, a socially optimal equilibrium that's different from that previously shown market equilibrium. The socially optimal equilibrium says we as a society would prefer that you consume fewer cars than you would if you only considered your own personal costs and benefits of consuming the car. And that socially optimum equilibrium has a higher price and a lower quantity. So how do we fix that? How do we move our market equilibrium toward that socially optimum equilibrium if these are costs to someone other than me? If it's a cost to you, then why should I consider that cost as I'm deciding whether to buy and use a car, right? Well, we can help have people internalize that that social cost. So help make that social cost part of my private cost through policy. One of those policy options is tax. So if we could figure out what those external costs of car consumption are, then we could add a tax equal to that external cost to the price of a car. And so when we do that, or to not necessarily the price of the car, but in this case, what's happening is we're adding a tax to production of the car. So the producer has to pay a tax. And so what that does is it increases the cost of production for the producer, and in a sense makes that external cost an internal cost. Now you're making it their problem, right? It's part of my private costs if I have to consider it, if I have to pay that tax myself. And so that will tend to move my internal supply curve, my private supply curve, upward. Because the cost of production is higher, and it will move up by the amount of that tax. If we can figure out exactly what the external costs are and tax production by exactly that same amount, then it will move my private marginal cost up to the social marginal cost, and will end up at the socially optimal equilibrium. Even if we can't figure out exactly what those external costs are, if we know that they exist, we can use a tax to move that private supply curve closer to the external, or to the social supply curve, even if we can't get all the way there. So your book goes through some discussion of other types of externalities, and some economic studies that have tried to figure out the monetary value of those externalities. And then on the other side, what we've talked about with the automobiles is a negative externality, where what I do causes a cost to someone else. There's also the case where there's a positive externality, where what I do can it has certain benefits for me, but also has benefits for maybe my neighbors. So one example of that is the use of solar energy. Sure, solar energy in some sense saves me money, but it also benefits you, my neighbor, by helping the environment, helping to clean up some of our pollution and waste and things like that. And so there is a social benefit that is above and beyond my personal benefit of using this type of solar energy, or doing whatever this uh, activity is. And so the supply and demand model looks something like this, where the social benefits are higher than the private benefits. The demand curve, the social demand curve, is up higher than my private demand curve. And the socially optimal equilibrium is to the right of the market equilibrium, where if we could if we had what's best for society and not just best for private interests, then we would end up consuming more solar energy than we do if we only consider our private benefits. So how do we fix that? Well, we do the opposite of a tax, and that's a subsidy. So if the government with some policy could subsidize the use of solar energy, or in other words, pay me to use solar energy, then we end up shifting the private demand curve up toward the social demand curve. Or on the other hand, actually what's being shown in this picture, is that they're subsidizing the production of solar energy. And so we shift the private supply curve down, because we reduce the cost of production of solar energy. And so we shift the private supply curve in a way that gets us to that optimal, socially optimal level of output. So either one, you could subsidize the demand side and move the demand curve closer to the socially optimal demand, or subsidize the supply side so that the equilibrium moves closer to that socially optimal equilibrium. That's what's actually shown in this picture, is the supply side subsidy. And then we can go through, I'm not going to go through all of the details of this. Your book does a better job of describing it, and it's really something that you probably spend a lot of time on in principles. But it goes through a welfare analysis of what happens when there's an externality. And so if there's no externality, we know that market welfare or benefit to the market is maximized at the market equilibrium. So we have consumer surplus, which is area A, and producer surplus, which is area B, and the sum of those two is total welfare, and that is maximized if we're at the market equilibrium. If, however, we have an externality, that's not the case. If we have an externality and we stay at that market equilibrium, we have a problem. We're actually producing more than is socially optimal, which means we end up with area C of what's called deadweight loss. We end up with an area where here we have costs of production that are higher than the benefits of production, right? If we consider the social costs, then we're actually producing beyond the point where benefits outweigh costs, right? So if we go back, the reason that this point maximizes surplus or maximizes efficiency and welfare is that we have at that point consumed all the way to the point where benefit equals cost, right? If we stopped early, we'd be leaving some benefit on the table, right? So as long as the benefit is higher than the cost, we want to keep consuming. But if we kept going out here, the cost is higher than the benefit, and we would be causing ourselves pain to do it. So we don't want to keep going. That's why this point where benefit equals cost is the place where welfare or happiness is maximized. So when there's an externality, if we went all the way to that point where our private supply and private demand meet, we've actually exceeded the point where total costs and total benefits meet. And so we've kept that's this point where the social cost and social and total demand meet is where we should have stopped. But we kept going all the way to the market equilibrium, which means we've consumed this triangle where costs were higher than benefits. So we have cost ourselves some of that welfare. And that you would see a similar argument on the positive externality side. And this is sort of why it's good to have some policies that try to move those internal curves toward the social curves. So here, with that tax, we move back up here to where the total cost equals the total benefit, and we no longer have that extra space where we're consuming too much. We then move into the last part of the chapter where they discuss the Coase theorem in detail. They explain this graph and talk about how the Coase theorem works. Basically, the Coase theorem says that property rights, if they can be assigned, correct for externalities. I'll post more information about the Coase theorem in a separate video, but I encourage you to read all about it.